Hello, everybody. Welcome back. This is lesson 21, review of complex numbers. In this first video, we're just going to give the basics, like what are complex numbers, and then remember how to do the basic operations, adding, subtracting, multiplying, and dividing them. All right, here we go. So, where do the complex numbers come from? Well, if you take the real numbers, those are the ones you find on the number line. And then you ask, is there anything here that gives you a square root of -1? And as you know, there's no real number that does it. That is, you can't square any real number and get -1. So, what do we do in math? We say, well, let's try to expand these numbers into ones where there is a square root of -1. So we make up this new number. We call it I, and I is just equal to the square root of -1. This thing, it's known as the imaginary unit. Unit is just like the basic number. In the real numbers, the unit is 1. In the complex numbers, the imaginary unit is radical -1, or I. And if I is equal to the square root of -1, of course, then the important fact is that if you square both sides of this equation, we get that I squared is equal to -1. This is some kind of number that when you square it, you get -1. And as it turns out, with this small addition, you can actually, if you look at the numbers that you get, if you throw I into the mix and you add, subtract, multiply, and divide it with real numbers, it turns out you can take the radical of any negative number and lots of other things as well. So adding a square root of a single number, -1, actually allows you to take square roots, in fact, any kind of root of essentially any kind of number. The system that you get, which is called the complex numbers, it just works amazingly well. Okay, so what are the complex numbers? The complex numbers are all the numbers you get if you start with the real numbers, and then you add this I, and then you see what you get. So complex numbers, these are just numbers of the form A plus B I, where A and B are real numbers, and I is this imaginary unit. I is the square root of -1. You'll notice if you have real number A plus another real number B times I, you can't add these together because they're not like terms. That is to say, you can't combine them. And so they stay like this. They sort of stay, the part that has the I in it stays separate from the part that's just a real number by itself. And we have names for these two parts. So we call this part, the A is the real part, and the B is the imaginary part. And the real part and imaginary parts together, they make up the complex number A plus BI. Okay, so that's the setup. And when we refer to the complex numbers in writing, the complex numbers are represented by this capital C with this with the extra slash. That's a blackboard bold. Those are the complex numbers. And that's just like how, if we're talking about the real number line, the real numbers are like that with an R. Those are real numbers. Okay. So, how do we picture the complex numbers? Here's how we do it. If we just go back up to my original picture, we had pictured the real number line here, and we've added on this new element I, and the question is where to put it in the picture, because I is not a real number. It doesn't belong anywhere on this number line, so it has to go off the number line somewhere. And the place where we put it is, we just go off at a right angle, this direction. So we move up 1, and this is the number 1I. And if you just extend that into another axis, then what you have is here the real numbers, and here the purely imaginary numbers, and then every point on the plane has a real number part and an imaginary number part. Those are like the x and the y coordinates. And so we would plot a point a plus bi, that's a complex number, we would plot it as a point here. A plus bi, and if you want to think about that in terms of our usual coordinate plane, all we're doing is just using the a, the real part, as our x, and the b, the imaginary part, as our y. And when we look at a picture like this, we call the x-axis the real axis, and we call the y-axis the imaginary axis. So this is the idea, and when we think of the plane in this way, as where if we think of each point as having a real part and an imaginary part, then this plane we call the complex plane. So you can graph numbers on it and so on, and you can think about what happens if I have two complex numbers, one here, and I add them together. Where does that end up? There's a nice geometrical interpretation of that. There's also the question, if I multiply or divide or subtract two numbers, where do they end up in the complex plane? And what we're going to do is we're going to see first how we add, subtract, multiply, and divide complex numbers. And then we're going to do a little bit of an excursion into thinking of complex numbers in a new way. And that will give us a way to picture how they are multiplied and divided more easily. So that's a little bit of an outline. Right now, we're just going to proceed to recall, when you're dealing with complex numbers rather, how do we do the basic operations? So this is example 21.3. Perform the operations, and there's an addition, a multiplication, and a division. So part A, we have two complex numbers, 2 minus 3i. That is one complex number. It has a real part 2 and an imaginary part -3. And then we're adding another complex number, -6 plus 4i. And the right way to think about this, if you're trying to get your brain to jump from working with real numbers, adding, subtracting, multiplying, and dividing them, to working with complex numbers, is think of, even though this looks like it's two numbers, think of this entire parentheses as a single number, a complex number. It's just a new kind of number. It's a number in this system that has a square root of -1 in it. And similar to this one. So although it looks like there's sort of 4 different numbers here, there are 4 real numbers here, there's really 2 complex numbers here. And when we add 2 complex numbers, what do we get? How do we do it? Well, here's the way we do it. We simply add the like terms. So the 2, which is the real part here, we add to the -6. 2 plus -6 is -4. And then -3i and plus 4i, treat that I like a variable, like an x. When you're adding, subtracting, -3i and plus 4i gets you plus 1i, or just plus I. So our answer to this 2 minus 3i plus -6 plus 4i is -4 plus I. It's the complex number that has real part -4 and imaginary part 1. That's it for problem A. You might pause the video here, go ahead and work through parts B and C, and come back and we'll work through them together. And remember, in every case, our goal is always to give an answer in the form a plus bi, the form of a complex number. So that's what we're shooting for. You'll notice that so far we've gotten an addition problem and we've gotten our answer in that form. Okay, let's go on to part B. In part B, 3 plus 5i minus 7 plus I, and they are multiplied. And to multiply these, we multiply in just the same way we would multiply any two parentheses with two items, any two binomials in together, which is we would distribute, or we would use the FOIL method if you prefer. What's important is that we have to multiply each of the things in the first parentheses by each of the things in the second parentheses. And then in the end, we will combine like terms. So here's how it goes. I start with 3 times -7, and that's -21. Then 3 times I, so that's plus 3I. Then 5I times negative 7. The 5 times negative 7 we multiply together and get negative 35. The I we keep there. And then 5I times I is going to be 5I squared. So that's our initial multiplication. And now we simplify. For example, the two in imaginary parts in the middle, plus 3I and minus 35I, we can add those together. I'll keep that negative 21. Here, this is going to give us a negative 32I. And 5I squared, we know what I squared is equal to. I squared is always negative 1. So we have plus 5, and that I squared becomes minus 1. Now, that final term, 5 times negative 1, is a negative 5, and we can add that negative 5 onto negative 21. Negative 21 and negative 5 is negative 26 minus 32I. This is a complex number. It's written in the standard form a plus bi. The real part is negative 26, and the imaginary part is negative 32. And that's the result of multiplying the two complex numbers that we started with, 3 plus 5I times negative 7 plus I. That's it. All right, part C. In this one, we're dividing two complex numbers, 5 plus 4I over 3 plus 2I. And the trouble here is that we would like to get our answer in the form equal some kind of a plus bi. That's the form that we want, but it's not clear exactly how to do this using the rules of algebra. And so to accomplish this, I'm going to ask you to cast your minds back either to previous exposure to the complex numbers or to the work that we did on radicals when we were doing what we called rationalizing the denominator. The trick that we're going to use here is we're going to try to turn that denominator to get rid of the imaginary, the I down there. And to do it, we use the thing called the conjugate. We've used the phrase the conjugate before in the context of a binomial, two things added or subtracted, where you change the sign in the middle. And we're going to do the same thing here. So the strategy, I'll just mark it underneath, because this is the strategy we always use when we divide, is multiply top and bottom by the conjugate of the bottom. We're trying to get rid of the I on the bottom, and multiplying by the conjugate is good for getting rid of a radical. And even though it doesn't look like there's a radical here, think of that I as being radical minus 1. Okay, so this is our strategy. Let's go ahead and do it. We are going to multiply the top and the bottom of this problem by 3 minus 2i. That's the conjugate of the bottom. We change the sign in the middle from positive to negative. If the original sign there was negative, we would switch it to positive when we took the conjugate. And since we don't want to change the value of this fraction, we multiply the top and bottom by the same thing. Now, this is going to require a little work, and the reason is that we are going to need to multiply the bottom using FOIL. It might help, actually, if we put parentheses around these guys, like so and like so, and then multiply the top using FOIL. So those are the two parts that we need to do. I'm going to go ahead and put my answer, show my work down below here so I have enough room. Let's start with the top. On the top, we multiply using FOIL 5 times 3, we get 15. 5 times negative 2i is negative 10i. 4i times 3 is 12i. And 4i times negative 2i, well, the negative 2 times 4 is negative 8. And the I times I is I squared. In the next step, we will change that I squared into a negative 1. Okay, now let's do the bottom. Same way, 3 times 3 is 9. 3 times negative 2i is negative 6i. And 2i times 3 is plus 6i. 2i times negative 2i, the 2 times the negative 2 is negative 4. And the I times I is I squared. Now, what you'll notice on the bottom is very nice. The 6i, minus 6i and plus 6i cancel out. And what we're left with is 9 minus 4 times negative 1. Oh, I'm sorry, this looks probably quite confusing. That's just the denominator I'm working on. 9 minus 4 times negative 1, when I replace that I squared with the negative 1. Now, in the numerator, I'm going to add together my like terms. Then minus 10i and the plus 12i I can add together. So just keeping track of things, 15 minus 10i plus 12i is plus 2i. And then minus 8i squared, I'm going to convert that I squared into a negative 1 as well. On the top, you can now see that 15 is going to be able to combine with that term on the end. Minus 8 times minus 1 is positive 8. So this is 15 plus 2i plus 8 if we just simplify. Similarly, on the bottom, 9 minus 4 times minus 1 is going to be 9 plus 4. Okay. And then I think one more step will do it. On the top, we combine like terms. 15 plus 8 is 23 plus 2i. And then on the bottom, 9 plus 4 is 13. So first of all, we've rationalized the denominator. We've gotten rid of the I in the denominator. However, we have the following funny problem. This is not really in this form, a plus bi, which is supposed to be one number, one real number, plus another real number times I. So how do we do that for the final step? We're just going to take this fraction. It has two things added together on the top, so we can use this to split it up into two fractions, each over the denominator 13. 23 over 13, that is the real part. And if you want, you can take that I right there and move it to the side, to the front of the whole thing. Not the bottom, but just to the front. And that gets you 2 over 13i. This allows you to see clearly that this is a complex number in the what we call the standard form. In particular, it has real part 23 over 13 and imaginary part 2 over 13. All right, that's it. The next video you'll see what we're going to talk about is how do we view these through a slightly different lens instead of a x and a y, viewing them in what we call polar form as a point having a distance from the origin and an angle. And we'll see that in our next video.